Welcome to the Intersecting Us podcast, where math and life intersect.
In today's podcast, Brian and Dave discover the beauty in math.
It has been said that beauty is in the eye of the beholder. We're going to talk about that today on our Intersecting Us podcast. We don't know if we completely agree with that. That's certainly something we're going to look at. But before we do that, the last couple of podcasts, we've talked about meaning and play. And I know, Dave, welcome into the podcast. You've got some thoughts on that, maybe a little bit more, or just sum up some of what we've talked about. So before we get into the beauty part, let's get some of your thoughts there on summing up some of the meaning and the play.
Sure. Welcome, everybody. And I know we try to give about a half an hour to our podcast. And so we've dedicated about a half an hour to each of these topics. And for me, they've been really things that I've been living and experiencing, I'd say the last 5 years or so. And sometimes it's difficult to summarize everything in a half an hour. And after we did our podcast a couple weeks ago on meaning, one of the things I kind of thought about that, I don't think we really touched on, but I think it summarizes really the idea of why math has so much meaning to me. And I don't know if you've ever heard this, Brian, before, but sometimes people talk about math as a universal language. And so, the idea is it doesn't matter what spoken language you use, whether it be, English or Spanish or whatnot. Math is something regardless of the, verbal language you speak that we all can understand together. And I don't know, have you ever heard that expression before?
Yeah, it reminds me of a movie, but I won't go there. But it does. I remember watching it. It's a movie we've already talked about in the podcast. But when they're trying to talk to extraterrestrials, they use math, and I think they actually say the term that it's the universal language because it translates into anybody. Yeah. So I thought, I've heard that. Yeah.
Yeah. And if you think about it, it's not just like any language of how we think about today, but it's also timeless, and that people from other cultures, and we often pick on the Greeks, 2,000 years ago, I don't think they spoke English, right? The Greeks?
I'm thinking not. Yeah, that didn't come along for another.
Greek to me, right?
Yeah, exactly. Yeah, I think it was.
I know you study Greek, so you probably have a little appreciation for that language. But think about it, that era, these people, I know that they were quite different than us. They didn't have smartphones. Their culture was way different than ours. They spoke a different language, and yet we can look at triangles together and see the same Pythagorean theorem. And that's something that I think is easy to miss. And it's kind of, it's a meaning thing, but it also kind of highlights the beauty. And we'll probably get into that a little bit too. But I mean, that's just kind of cool. Don't you think that that's neat how we can go back in time and share something together?
Yeah, it is kind of neat because, again, what you're trying to do is just transmit information, knowledge. That's what communication really is. And so being able to do that over time or over anything that is different is kind of cool.
Right. So anyway, that was the thought I had on meaning. And then on play, again, I could have talked on that, I think, for a long time, because one of the things I really love doing is playing with math. And that's where math comes alive to me, is not when I'm trying to solve a business problem, but when I take time to just play with it. And I was talking to my wife about it after our podcast. And as I know you, Brian, Julie, and she super smart gal, but math, I wouldn't say, is her top subject. In fact, just probably one that she would say is one of her least favorite subjects, although she's still good in it. But she's really good with kids. And as I was talking to her about play, actually, I didn't even mention play. We were talking about something, and she started talking about how important it is for kids to play with things before they study it. And she was referring to math. And so like 3 or 4 year olds. And I was asking her, what do you mean by that? And she said, like, if you give them blocks that might be manipulatives that they're going to, do something with, before you can really expect them to maybe learn something, they just need to kind of like play with it and, stack them up, knock them over, all those kinds of things. And I know that it sounds very simplistic, but, we definitely lose that ability to play as we become so smart and, sophisticated as adults. But, you and I, we've got grandkids now. I think we're reminded how much fun it is just to play.
Yeah. And I as you say that, we talked about that obviously at length in the podcast with play. But again, it was the enjoyment part. I think, if you take the play out for the kid or for the adult, it becomes a work or a job or a mundane, and it takes that out. And the whole thing we talked about with imagination, let the kid imagine what might, work here and what might not, and that's, yeah. And then constructive things can come out of it. We even see, there's different people today in different companies, different innovators, and they kind of play around with stuff until they figure out what makes sense, and that's work, but yet they really probably don't feel like it's work because they're playing with it, trying to figure it out. So I guess kids can teach us there. So,
yeah. So anyway, if these ideas are new to you with regard to math, the idea of math has meaning and that we should play with math, I really encourage you to go back to those podcasts and listen to it, or just give it some thought the next time you are thinking about math, and try to work on those things and see if you can incorporate some of that into your life in a practical way. Because for me, it's been a real game changer. And that's why I really wanted to review these topics real quick, just to highlight them, because I think that, it really hits the nail on the head.
Yeah, I think it does. It's always good to go back and look at those. But today we're going to talk, which all of these topics do kind of run together in a good way. They complement each other, and beauty is one of those things. I started off with the idea of beauty being in the eye of the beholder. And I think one of the things we try to do is something that's a little bit more hard to get our minds around, like beauty. Philosophers and ascetics and all kinds of different folks over the centuries and millennia have tried to figure out, is it subjective, meaning that it's dependent on the observer? That looks beautiful to me, it might not to you. Or is it objective? It depends on the qualities inherent in the thing that you're looking at, or the object being admired, or however you want to put that. And I think that's a big question that I don't know, a lot of people punt on, because it's hard. How do you see? I guess you could debate it. But one of the things I think to ponder a little bit is if you see something beautiful, I think maybe to use a good a story and analogy for us, we had friends, and you and I, Dave, and other friends, we went and saw and hiked the Grand Canyon. And that's been a number of years ago. And, when you see it, I suppose there's that one weird person that wouldn't see it as beautiful, but it's kind of just implied that there's some sort of, I guess we'd call intrinsic quality to it, that beauty is a property that we'd all say, yeah, that has that. But the idea of sharing it with someone else, if you see something beautiful like that, yeah, you can experience it on your own and ponder and all that and be introspective, but it's kind of fun to then say, hey, go look at this. And then you share it with the person, and you get to share it all over again, and they get to share it for the first time. And so that beauty has that quality. So I don't know if you've thought about that deeply, but I suppose if we had to ask a true or false, yes or no question, is beauty only subjective, or are there some objective inherent intrinsic qualities of some things that we can say they're just by definition beautiful? What would you say to that, Dave?
I would say that there are probably a few things, a smaller subset, that would be objective for 99.9% of the population. And but then I think a lot of the areas would be more subjective. And you may find on some things like 2/3 of the people would consider it objective. But then when you get to math, I think you're going to be hard pressed to find a lot of people that see math as beautiful in an objective way, which is fine. But I think if you talk to people who who I would call mathematicians, who really study math and not just the practical application, but the theory. I think you're going to find within that subset, that subculture, a lot more objectivity to what is beautiful.
Yeah, and I think that bringing the math in, I know, and again, just to kind of reiterate, we're kind of springboarding a lot of our discussions off of a book by Francis Su called Mathematics for Human Flourishing, and this is the chapter name that he talks about here is beauty, and we're using some of his ideas there, a lot of our own. But the idea in the past chapters, he's talked about the idea of patterns. And I think in this beauty chapter, he talks about that too. From a mathematical standpoint, it's these patterns that tend to give us the beauty. And he even has some, I think he had some mathematically generated, I don't know if that's the right word, figures, but then saw the beauty of them because there was patterns there, or a beauty of a pattern of, I know he was doing something with prime numbers, and it's like there's a pattern there. That it's not that beauty equals pattern, but in math, or in architecture, and he used that as an example, and other things, having some sort of symmetry and pattern tends to be what we would see as a property of being beautiful, not haphazard, and even in that it could be, but that seems to be the thing. And I think the thing that was really cool, and that's what we try to do here, is that math you can make a case that the beauty of math can be so much more objective because of its foundation. And it's not like, because when I think of beauty, a lot of times it has to do with emotion. It doesn't have to do, it might have to do with just sensory perception and all that. But it really, it's almost like, I don't think you have to be emotional about something beautiful, but it tends to be when you experience the beauty. Whether it's another person, or like you said, a Grand Canyon, or you look at you think about going somewhere, and if you like the ocean and you go on a beach and this is sunset and the beautiful oranges and pinks and hues and all that, yeah, that has kind of a neat quality, but there's a part of that, just how does that make you feel? What makes you feel? That's what get different types of beauty. There's kind of we talked about sensory beauty, but this is more like wondrous beauty. There's awe and there's amazement of what's there. And so it's an experiential thing, I think, in both ways. It's not that let's set up and do a nice, beautiful proof in math. Well, we don't start that way. You just start playing with it and you come up with patterns, and then the beauty kind of imposes itself on you. And however that the awe, maybe the wonder, and which and we've been talking that the joy quality kind of comes in there. That's kind of part of what we talk about too. So yeah, I like the way you put that. I think most people might not see it, but I do think math in itself can help us see beauty in a more of objective way, that there's some sort of intrinsic value there, because it's a pattern we'd seen before that we saw beauty in, and now we're seeing something a little bit different, but there's similar patterns, so we're seeing more beauty here.
Yeah, I liked how Sue quoted in the quote, he said, while sensory beauty usually concerns itself with physical objects, wondrous mathematical beauty always invites a dialogue with ideas. And, ideas is abstract. And so, how can something abstract be beautiful? And for me, the idea there is you start to see connections where you aren't expecting connections. And so let's try to think of something abstractly here. I'll test your brain a little bit. So if we think of a circle and take a diameter to that circle. So let's think of a clock, and the diameter could be like from 3 o'clock to 9 o'clock. So there's your clock, there's your diameter. And then as you think about choose any point on the circle, not on 3 or not on 9. And so just take something maybe on the north side of that. So a number between 9 o'clock and 3 o'clock. So it could be, like right at 12 o'clock. It could be at 11 o'clock. It could be, halfway in between 11 and 12, or anywhere in between 11 and 12. And if you take that point and then connect it to 3 o'clock and 9 o'clock, what are some things you would notice about the side lengths of those connections between let's just start at 11 o'clock. You would go from 11 to 3 and 11 to 9. What would you notice about like the lengths of those distances?
Are you talking about the circumference part or the lines between them?
I'm just talking about the line part. So like think of the second hand.
So the lines, there's gonna be. I mean, what you would notice is obviously they have a limit, which is on the circle, but that they change. There's a length it can't get any higher than, and it keeps repeating.
Right. Yep. And so they would be equal like at 12 o'clock. If you had a hand pointing from 12 to 3 and 12 to 9, then those distances would be equal.
Right. Yeah.
And then if you just move that dot, to the left or to the right, then one hand's going to get smaller and one hand's going to get bigger. So I think that's pretty self-explanatory. It might be a pattern, may not be super insightful, but now think about the angle so now think of a triangle. And so it's a triangle that changes shape because as the dot goes around the clock, you always have the diagonal from 3 to 9, but then your third point goes anywhere between, let's say, 11 and 12. So this triangle kind of changes shape as it's going around that circle, right?
Right.
So what can you tell me? What do you think about that angle that triangle has with that point that goes between 11 and 12? So there's some angle it makes when it points to 3 and when it points to 9. What do you think? Is there anything about that angle that you would anticipate? So we're trying to imagine this idea.
Well, and it seemed like at some point, you would be seeing, a right triangle present itself on there.
Right. At some point, it probably would be right and so I'm going to jump to the punchline here. The fact is that it doesn't matter what points you choose. Any point between 3 and 9 creates a right triangle.
Yeah. Okay.
And so
it's equilateral at 12, but it's right everywhere.
It's equilateral or isosceles at 12.
Right.
Isosceles at 12 because two are the same. So that you can maybe see it as a right angle, but that as that point moves, the lengths change from longer or shorter, but the angle always remains 90 degrees.
Yeah. Okay.
And so to me, that's kind of like if you imagine like that point going across that semicircle, changing and seeing the lengths of the triangle change, but the angle always remaining 90 degrees. That little animation to me is kind of like a beautiful thing because I wouldn't expect it to. It didn't seem like it would, where you kind of thought about like yourself, like there's some point you might expect it to be 90 degrees, but you wouldn't expect it to be always 90 degrees, but it is. And
yeah, I didn't, as you say it now, it makes sense. But I was just thinking about the 12 o'clock, as being definitely a right angle. But yeah, makes sense when you. I mean, if you think about the point,
let's say right above the 9. So I guess that would be at the 46 minute, and the 9 is at the 45 minute. So you just have a very small side on the one part of the triangle, and then a very long side on the other part of the triangle that reaches over to 3. And so that triangle has a very different shape, yet the angle there remains 90 degrees, which again would not be something that I would anticipate. But I've watched that kind of animate, and as I've seen that animate, I found that is a really kind of like a beautiful idea.
Yeah, and I think that shows a little bit what we're talking about here in the instance of it could just be a sensory beauty, but it could be there's some wondrous beauty. Like, well, that's kind of as you do it. I remember when I was a kid, but they had that. It was called spirograph. It was you had a pen, and it kind of did stuff like that. It would kind of draw for you based on what things you were using around a circle or something, and you'd start and you'd get done, and they were pretty cool art, I guess, if you want to call it that, with some beauty. But you also mentioned that as we get into the, I don't know if it's called deeper stuff, maybe a little more esoteric. There's this thing called like insightful beauty that he mentions in the chapter. The idea of the beauty of understanding. I know the term I'd like to use is, you'll talk to somebody about maybe it might be maybe a deeper concept, but eventually, or if it's just trying to understand a discipline like science or math, I'll say eventually the change falls into the meter. It's kind of like it's just sitting there. You can see it, but eventually it falls into the meter, and you're like, oh, this makes sense. This fits something. It's another beauty he was talking about, because it has to do with reason. You're able to think about, you're thinking about something in a way and understanding it in a way that you hadn't before.
Right.
And there's an elegance to that. And I think certainly we even have the term in kind of mathematical disciplines called an elegant proof, which it's got a subjective quality to it. Well, one elegant proof to one person may not be to another, but it has to do with that understanding. You're able to do it. I could have done this in 47 steps, hodgepodge and prove, but I did this in 4. And it's just an elegance to it, and it has symmetry, and and that's the kind of thing. And that's true in anything. I mean, you could have an elegant, an insightful beauty with a person. They always kind of do this, and I always didn't quite understand it. But then the change falls in the meter, and you're like, oh, that makes sense. And it's not a beauty of, well, they look nicer to me. It's a beauty that their actions now make more sense to me. And gives me, and so there's some awe there too, I guess. But it's the idea that now I understand, and that's such a big part of anything in life, but certainly in math too.
Yeah, and this one I really can relate to, because it's motivated me to create some videos. That the reason why I created the videos was simply because of what you're talking about. Was that I just found the proofs or the logic to be so beautiful. And I just love it when maybe at one point I learned a proof that, like you say, may have taken 2/3 of a page of algebra. And then all of a sudden I stumble across another proof. And the example I was thinking of was the Pythagorean theorem. And then I saw another proof that I was able to understand with just one picture. And so, the whole idea, a picture's worth 1,000 words. Well, to me, that picture was worth more than 1,000 words, because I'll never forget that picture and I'll never forget that proof. But I could easily forget 2/3 of a paper of algebraic symbols. And so there's something about going from something that seemed to require lots of abstract steps and X's and Y's, and now all of a sudden you see it in one picture. That is when there's this, I would say, this third type of mathematical beauty that is insightful. And I saw that with the Pythagorean theorem. I saw another one where the square root of 2 was proved to be irrational. And so these are some classical proofs from the good old Greeks that have been looked at by generations of people and cultures. And most of the proofs have been done through the algebra approach. And then when you stumble across something that is more pictorial, well, then that's where it really becomes, pretty awesome.
And all these almost are stair steps. The 3 types he's talked about that gets us to the 4th type here. The idea of the sensory and the wondrous and the insightful. They're not really stair steps. They intersect, but you get to the point where there's it gets more into your mind and less into your hands-on stuff. The experience is still there, but I think the last one he talked about, which I thought it's a good word. It's just the word transcendent. It just means, it's the idea of there's transcendent qualities. Transcendent means it's outside yourself. It's and it permeates more. Immanent means it's kind of inside ourselves, and so they're kind of almost opposites, antonyms. But so something transcendent. What would be transcendent beauty? It's really something that where you go through all these things and you find some sort of greater truth that starts popping up in everything. That's the idea. So it's like it's almost imposing yourself on it, or it's imposing itself on us. The idea, he was talking about how Einstein, so much into math, but yet also his experience, and he saw how math, just what he would have seen probably early in his career, is just arbitrarily intersecting and showing that the math and reality seem to be lining up all the time. And he keeps seeing that over and over again. Well, that's transcendent. That's the idea of a greater truth of some kind that there's a deeper significance here, and seeing that as beauty is kind of interesting. You could say, we'll talk about truth in the future as another chapter, but seeing transcendent beauty, it's almost like as a scientist, you could look at it as, or just a general person, as kind of an inductive method. You see all these little evidences and experiences, but then you start seeing these patterns that keep coming over and over again. So you have this from these little detailed things, you get this general rule or general hypothesis that transcends them all. And the way he talked about that was it almost came, you had to have some of the sensory stuff. You had to some of the awe, and you had to have some of the obviously understanding to get to that point. It's almost like, I think he called it like an aha moment, which I kind of liked. It's like, oh yeah, I saw that the last 19 times. Maybe there's something here. That's
that. And this transcendental idea really probably trumps the other three because of its permanence. And I don't think Sue mentioned it, but in math, we even have a term for a transcendental number. And I'm not going to get into the details of it, but mathematicians have a category of numbers that we call transcendental. And then the first one that was determined transcendental, I can't remember, it's either pi or e, one or the other. But, those are two probably the most well-known numbers in math. And both of them are transcendental. And I think what's really cool is how they have captured the imagination of so many people for so long of a period. And yet they're just numbers. And to piggyback off an idea we talked about earlier that I think there was in the meaning section, where numbers in themselves aren't meaningful, but what gives them meaning is their relationship to other ideas. And so if you take the number E, well, that's just a number, not very interesting until you start seeing how it connects to, so many different things in math. And Euler came up with an infinite sum where you take the sum of that infinite sum and it equals E. And that was like a big story in the history of math. And so that's kind of like a gem that we've been trying to uncover and find new sources of beauty in that one formula, for over 200 years. And so, there's just so much to unpack once you start seeing math as surprise connections between ideas.
And when you see those ideas continue to show up some sort of quality, I think that's kind of the way we look at it. A beautiful quality that seems to keep showing up. It's kind of almost like kind of trying to communicate to you this part, but you can't quite figure out the source yet. And you see that in a lot of the innovation in math, and you see it in innovation in science, where they're doing this, and it's transcendent, and it's just not something that you see that just everybody can see. It's something you have to work at and experience, and then it kind of imposes itself on, but something's there, and you see that in almost all great inventions of the mind, whether it's mathematical or scientific or even religious. There's this idea of continuing, and in philosophy, you see this. They keep working at it, and then eventually something imposes itself on some. There's this transcendent, didn't see it, saw pieces of it, but finally you find kind of the source. And then most philosophers will say that that's just a start, because you probably haven't exhausted of what that transcendent beauty is. But it's why we call it beauty. It's because it has a quality of awe, has a quality of knowledge, has a quality of joy. and of emotion. It's not just mundane,
Right.
People get excited.
That's right. And you think of things that have captured people's heart and attention over the years, the kind of the yin and the yang, the good and the evil. Those types of things are things that artists try to capture. And I think one of the things that mathematicians have been able to appreciate and wrestle with in that yin and yang idea is to wrestle with the tug and pull between the finite and the infinite. And I know you and I have talked about this a lot, but we all have in our mind some sort of idea or imagination about what could be infinite. And we can't reach that. We can't get there. And yet we wonder what it would be like. And is there infinite things that are true in this finite world that we live in? And so there's like this deep mystery that has, that we have pieces to that puzzle, but we'll never get all of the pieces to that puzzle. And math has some incredible ways of looking at that mystery and shedding light on it that no other perspective can do. And it's something that mathematicians, whether they're religious or not, still appreciate, kind of like that transcendental mystery of what it could be finite and what is infinite, and how do those two ideas kind of work together and come together.
Yeah, and then sometimes it just falls in and people see it, but at this point you get the idea of pursuing it. Are you pursuing beauty? Are you trying to, which takes patience and it takes diligence to see those things. But within that is the joy and the emotion that comes with it. So I thought I'd end up with a quote from Sue that was really what kind of just sums up the chapter, but it sums up a lot of things, I guess. It is about pursuing beauty. But he says that pursuing beauty of any kind, not just in math but in life or anywhere, cultivates in us the virtues of reflection, joyful gratitude, and transcendent awe. I thought that was a very good way to sum up that you pursue it, and then it's not that you keep finding beauty all the time, which you may, but it causes virtues, good things. As we talk about beauty, goodness, truth, and within that some joy. So with that, we thank you for joining us on our podcast. We hope that you find this day that you're listening to this, maybe some beauty in your life, but always be pursuing that, and always remember that whether you're doing math or life, there's a lot of beauty in there. And if you want to pursue it, you'll find it. And then we encourage you to share it with somebody once you find it, because that'll give you deeper joy than anything else.
This has been the Intersecting Us podcast. To further engage with Intersecting Us, go to intersectingus.com.